Okay, so we can start now.
Yes, yes, sure. Thank you.
Okay. I just wanted to go to the previous. For some reasons, I cannot go back to the previous slide, but okay, here it is. Okay. Okay, so just a short overview of what we are going to see today. We are framing some basic sustainability concepts and also have an overview on some general sustainability policy and design case studies. The perspective will always be that of materials. So the final slot is concerning what the role of materials is in all these policies and approaches to sustainability. Generally speaking, the course is organized in 4 modules. The first is more general and more probably also a little bit more theoretical. And can you please switch off your microphones? Okay, thank you. So I was saying the course is organized into 4 modules. The first, which is the one we are having today, is the more general and more, let's say, theoretical in a way. So don't worry, we will be much more practical and talk more about tangible materials with examples and everything in the next 3 modules, which are respectively concerning recycling, concerning bio-based materials, and the 4th is more concerning waste. So waste in terms of potential resource and also in terms of waste management, what to do out of a company's waste. So let's start with the first group of concepts. Clearly, talking about the planet crisis and related environmental issues, we have different perspectives from which we can look at the problem. So these are, how can I say, perspectives, so points of view that consider the same problem with different tools and different eyes, I would say. So the first is climate crisis. Then we have pollution, then we have loss of biodiversity, and we have overconsumption of resources. So these are clearly the, let's say, 4 different angles of the same things, but each of these concepts have slightly different languages, different ways of looking at the problem. So I would first ask whether you are familiar with these concepts. So we were supposed to have this as a questionnaire, but you can write in the chat what's your perspective on these concepts. So for instance, when we talk about climate crisis, do you believe yourself to be, okay, I've heard about it, or I am an expert, from 1 to 5?
So we start with climate crisis, only this
yes,
one.
We put 1
crisis. Or 5.
Can you please rate your knowledge of climate crisis of the concept of climate crisis? Okay, 3. Oh, okay, everyone says 3, which is the standard answer. Medium, average. Okay, that's good. That's good. So And how about the concept of greenhouse gases? Okay, here we are more 2, 2, 3. And okay, great. Okay, then we have global warming potential. Then we have carbon footprint. Okay, so quite a broader range. We have experts on carbon footprint, clearly, and others. Okay, carbon neutrality. Okay, LCA. Okay, and circular economy. Okay, so I would say that most of you are pretty at a good level of knowledge on all these concepts. So clearly, we would not go very much in depth. This will be just an overview. So I may go quite quickly on these concepts, and then in the end, for those of you who are really expert, this may be like probably something that you've already heard about. And for others, it can be, let's say, an interesting and useful rehearsal. So for each of these concepts, we have set up a slide that summarizes what is it and what is the difference between the different perspectives. So when we talk about climate crisis, we mean the critical state generated on the planet by the increase of global temperature, so by the so-called global warming. And clearly, the main cause of global warming is the emission of greenhouse gases, which started from last century. And there is, of course, a general consensus about this. These greenhouse gases can have a biological origin or be fossil-based. CO2 emissions are typically fossil-based and concern the release of extra carbon beyond the natural carbon cycle. So the problem is clearly concerning the extra carbon. The effects of the climate, of the global warming, are more and more extreme weather events, melting of ice resources and consequent rising of sea levels, climate change in single areas, desertification, etc. And the policies that address the climate crisis specifically are mitigation activities that are driven by carbon net zero policies. Clearly, there are also adaptation, but adaptation is not the object of this course. This is something different. Then we have pollution. So clearly, there is a difference between climate crisis and pollution. And in many cases, there is a confusion about these two levels. Pollution is more a local phenomena that occurs when an excessive quantity of harmful substances are released into the environment, which affects the quality of life of living organisms in that specific environment. So the pollution is caused by typically industrial activities, also by agricultural activities if uncontrolled, locally, for instance, by emission of transport, heating systems, and by waste mismanagement. So the effects of pollution are the most direct and visible form of negative impact of human activities on the environment. It affects air, water, and land. When we think of materials and pollution, one instinctively thinks of waste, of landfilling, of mismanagement of waste disposal, etc. While recently there has been a much higher concern on how materials affect the climate crisis rather than local pollution. So the policies are addressed by typically reducing emission waste and toxic substances at a local level, and particularly by managing waste correctly, especially when it comes to materials. Biodiversity loss is a sort of consequence, and it is also a perspective of the previous problems. So biodiversity loss refers to the decline or even disappearance of biological diversity, which is the variety of living things that inhabited the planet, its different levels of biological organization and their respective genetic variability. So the causes are clearly behind being caused by global warming and pollution, which we've seen before. Biodiversity loss is also a direct consequence of overexploitation of land and sea, reduction of living habitat, invasive or alien species, typically brought by human activity. We had the famous case of the blue crab in the northeast seas, as an example of alien invasion of alien species brought by human activities. So the effects of the loss of biodiversity can reduce the availability and quality of resources that are essential for human life, even of materials. So that would also affect somehow those that are called critical materials. And the policies to face biodiversity are typically directed towards the regeneration of the environment, which is one of the, let's say, directions that are currently more taken into account, especially when it comes to exploitation of land for materials, be them leather, be them stones, marbles, sand, wood, whatever. Finally, or it's not a chart, it's just an overall perspective. It's the overconsumption of resources. And this is very much related to materials. So we consume natural resources faster than their capability to regenerate themselves. Clearly, particularly when it comes to non-renewable resources, there is no way they can regenerate themselves unless with a very long amount of years. But still, the management of these resources that appeared to be infinite until 100 years ago, no one, with exceptions, but there was no concern by humans that we would have one day problems with the resources. When an area would be overexploited, we would just move somewhere else and exploit that specific area. But now, with having, let's say, globalized all the economy and land exploitation, this is not possible anymore. So the cause of overconsumption of resources is, on one side, the faster obsolescence of products, both technical and semantic. So there are some products that would become obsolete because of technical reasons. There would be a new release of something new, and others that would become old because in terms of their meaning, of their semantic language, and this is typical of fashion, for instance. And this is induced by the current economic paradigm, which is linear, as we will see. The increment of, and on the other side, we have an increment of in global population, especially of people that, of course, would like to have access to the same kind of well-being that we had access to in the last 50 years. So the effects of this is an overexploitation of resources. And this is exemplified by the Earth Overshoot Day, which is the calendar date that indicates the day when humanity's resource consumption for the year exceeds the Earth's ability to regenerate those resources. When it comes to Italy, I think we are July, something like that. So in July, we would, as a country, we have consumed all the resources that can be regenerated in that year. So we live on credit by using our savings for the next 5 months. So the policies to face overconsumption of resources typically are directed to regulations that to contain the exploitation of resources such as land, water, fish, etc., and regeneration policies by companies. So when it comes to key concepts, the first one is clearly circular economy. By circular economy, we mean a systemic approach to development which is designed to create long-term benefits, not only for business, but also for society and the environment. So the idea is that the circular economy would rethink products and services, not only to make them better, and by reducing their environmental impact. It's the idea of moving from a linear to a circular model. Just to make an example, there is a difference between, let's say, a linear sustainable thinking when it comes to materials, for instance, and a circular approach. So this is just an example to make it clear. When you think of cotton buds, for instance, those would, before the SUPD regulations, those would be made of plastic, no? So a linear sustainable approach would be that of replacing those cotton buds with another material. So bamboo, cotton, natural materials that would biodegrade or would be less impactful than plastic, etc. But the circular approach is rethinking the product. So in this specific case, for instance, moving from disposable to reusable. And the example here is that of a cotton bud that has been designed to last more than once. So that can be cleaned and reused, and that would be also designed for recyclability with recycled materials, and so be designed in the best way possible, but also rethought completely in terms of the concept of the product. So what are the three main drivers of the circular economy? The first is elimination of waste and emissions by means of circular design, of the creation of circular supply chains that would include recovery and recycling, and by making more efficient processes. The second step is longer life of products, so working on life extensions of products and materials. This is particularly true for durable products, like in the case, of course, of lamps and furniture. And this would be achieved by availability of spare parts and repair services, development of sharing platforms, and transitions from products to services. And we will see some examples later. And then the third step is regenerate. So regenerate the ecosystems where we will take resources from. So this affects the responsible sources of raw materials, elimination of harmful or toxic emissions to the environment. Clearly, all these areas are in many cases driven by regulations, by general regulations. You know this better than me, but companies can do more than what the minimum, let's say, requirements given by regulation. So do more than what's mandatory. The second concept that is that of carbon footprint. I've seen that many of you are already experts of this, so I would go quite quick on this. I have quoted the short sentence from the Paris Agreement, which is what has driven since then the main policies concerning CO2 emissions, which is setting targets to reduce those emissions. Just a small parenthesis. When we started working on, when I started working on here in this company, which was like 11 years ago, clearly sustainability was already at the center of all the reasonings, but it was more focusing on, especially when it comes to materials, on topics such as recycling, such as reusing materials, and that type of approach. Today, the perspective has completely changed. Clearly, recycle is still important, but carbon footprint is number one. So the idea that you can measure the impact of a material using the overall calculation of its impact on the environment is not that recent. I mean, it's becoming more and more important, and it's not that easy. So it's not that easy to precisely measure that. So generally speaking, when we talk about carbon footprint, we must refer to the natural cycle of materials. So we have on one side the emissions of CO2, which is naturally due to the composition of living beings and natural fires, expiration, etc. And on the other side, we have absorption of carbon, which is made by photosynthesis, by plants and phytoplankton, and by nutrition, so by the absorption by living beings of carbon to grow and live. Blue carbon is the one that is absorbed by the oceans, which is a big part of it. And then we have anthropogenic emissions, which are emissions from the industry, from agriculture, and the industry would typically come from hydrocarbons, and agriculture emissions would come from methane. And on the side of absorption, you would have landfills, because in a way they would just store carbon that has been stocked into some of those materials. So to rebalance the system, clearly there are two ways. On one side, acting on emission reductions, both in the natural cycle and particularly on industry. And on the other side, working on absorption via, for instance, carbon sequestration policies, by carbon capture at source or in operations, and without counting on landfills, which is a policy that will be eliminated. So the target is zero landfill. So what is, just to give an overview on the main wordings in this context. So when we talk about carbon sequestration, is the act of removing carbon dioxide from the atmosphere. So the term refers to capture and long-term storage of carbon dioxide in plants, material, and in the soil. So this long-term is a key wording also when it comes to regulation. So when a material can be called, can be, let's say, classified as a material that is that acts with carbon sequestration. All bio-based materials tend to carry out a carbon sequestration activity, clearly net of the impact of their transformation processes, but then how long it stays in that material is one of the key questions. So the next definition is that of carbon sink, which is any process, activity, or mechanism for removing greenhouse gases or any precursor of greenhouse gases from the atmosphere. So in short, a carbon sink is any system that absorbs more carbon than it emits. And the main carbon sinks are soil, forests, and ocean. So carbon sequestration is the activity, and carbon sink is the system where that activity is made. Carbon stock is the amount of carbon that's being absorbed by carbon sink systems. So the stock remains stored until the end of the material's life, after which it can be released back into the atmosphere following biodegradation or incineration. So the longer it stays in the material, the better. When we talk about carbon capture instead, we talk about technological processes. So it is not, let's say, a natural activity of absorption and sequestration and stock and store somewhere. Is a technological process that would capture and absorb carbon in an active way, I would say. And this can happen during the emission phase, which is where part of the emission is reabsorbed, or with specific absorption technologies. You may have read recently that one of the bigger projects in the United States for carbon capture has been dismissed. The project has been eliminated because of the rising costs and the imbalance between the costs and advantages, which is not a very good piece of news, but still there are studies and works in other projects to carry on technologies to remove carbon capture from the environment. There is a growing debate on which is the best strategy. So this is an interesting area to observe. To date, however, there are no carbon capture technologies that can generate artificial carbon sink systems that are capable of removing the amount of carbon from the atmosphere that is necessary to combat global warming. So there is still a long way to go to make this a viable way to help solving the problem. So in short, we have carbon sequestration and carbon capture, which are actions. The destination is carbon sink, and the quantity is carbon stock. And this can be done via also carbon capture activity and other absorption technologies. An interesting example of carbon sink materials clearly are all those that concentrate natural carbon into a material. So there is a new family of products that are based on biochar. And that can be composed of this substance, which is basically wood that has been carbonized with a pyrolysis process. And this sort of artificial coal, in a way, is incorporated into materials. There are several startups that are working on this. Clearly, this is just one of the possible ways of creating carbon negative materials that can be combined with other components to create carbon neutral, or in some cases even carbon negative materials. Then when it comes to carbon capture technologies, there are also some materials that have a natural carbon capture properties. There are some minerals, for instance, olivine, somehow even cement has some carbon capture activity, which is clearly small, but so there are several technologies that try to exploit the natural properties of some materials, typically minerals, to react with CO2, absorbing it into their molecular structure. So when we talk about carbon neutrality, what does that mean? Clearly, very easily, it means that the amount of the carbon released at the end of its life is equal to the amount that it has absorbed from the atmosphere during its life cycle. This is apparently very easy, but then when it comes to let's say, calculate or to achieve that carbon neutrality is not that easy. Most of the materials that claim to be carbon neutral apply some compensation, some carbon offsetting strategies. Typically, the reduction policies to achieve carbon neutrality are: one, the reduction of the impact of processes, so the optimization, the use of renewable energy, a shorter supply chain. Then we have the reduction of the impact of raw materials, so using recycled materials, bio-based, carbon neutral, carbon negative raw materials, etc. And then there is always a quote of compensation and carbon offsetting at the moment. An example of a carbon negative company, or carbon negativity, let's say, approach is that of Sebastian Cox, who is a designer who has set up its own furniture firm. They claim carbon negativity in all their business by using locally sourced wood. And by creating pieces of furniture that are designed to last. So by using wood as a carbon stock. In terms of balance of the quantity of wood they use as carbon stock and their negative, I would say, impact on carbon absorption, which is positive. So there is this always joke about negativity and positivity in this case. The company itself emits to manufacture the furniture far less than the quantity of carbon that has been absorbed by the wood they use. And what's interesting is that they also take responsibility of the staff's carbon footprint. So they calculate the individual carbon footprint of each of their staff. So not just when they in the workplace, but in their life. And they consider also that in the overall carbon footprint of the business, including it in the whole calculation. So this is, let's say, an interesting and sort of holistic approach towards furniture manufacturing in a carbon neutrality perspective. So how to measure all this? Clearly, the tool to measure and to track, in a way, the impact of a company's activity is LCA. Which is like life cycle analysis or life cycle assessment. In terms of materials, LCA is becoming more and more important because manufacturers are increasingly asking their suppliers to provide them an LCA. So what we are seeing is that we are moving from a database, I would say, data-based calculation of an LCA of a product. So let's say I make a product out of leather, and there is a database that tells me that the average impact of leather is this. And if I may compare it with, I don't know, synthetic leather or other types of leather replacements, always in a data-based perspective that considers the average LCA of that family of products. And what's happening is that companies are more and more asking single specific manufacturers to provide their own real impact. So what they do with their processes. And this is let's say an increasing trend, which makes clearly the measurement of the impact of a product more and more reliable. So what's the point of LCA? Clearly, the importance of LCA goes beyond the number itself, but it also helps companies designing their sustainability policies by understanding what's the most impacting phase in a product's life cycle. In many cases, it can be external to the company itself. For instance, you may discover with an LCA that the impact of your lamp, for instance, is more during the use of the product. So clearly making it more energy efficient is a priority rather than using, for instance, recycled materials. So after you have understood what's the most impacting area of your product in its entire life cycle, a company is able to improve the eco profile of the existing product and design better ones. Then you can use it to compare similar or different products with the same function, or, for instance, comparing different materials, and clearly communicating the environmental performance of the product via environmental declarations. So there are several types of LCA, starting from raw materials up to disposal. Clearly, in the life of a product, we have several steps. There is a very long supply chain, even for a material, right? So a single material is per se usually a semi-finished product. So there are raw materials, there are transformation processes, then another steps, then other raw materials added, other transformation processes, blah, blah, blah. Then it goes to the factory where you manufacture a product, and then it goes to the use, and then to disposal. So particularly when it comes to materials, normally materials, the LCA of a material is calculated cradle to gate. So what's the impact of a material until when it exits the factory, because the material manufacturer doesn't know what happens next. A product instead can calculate its LCA cradle to gate or cradle to grave. And then there is the cradle to cradle approach, which also consider strategies to bring materials to the beginning of the chain. What are the declaration types? There is type 1, which are eco-labels, for instance, the eco-label. Type 2, which are self-declared environmental claims made according to ISO 14021, and type 3, which are the EPDs. Clearly, having a third-party certified EPD helps. So that's let's say the most valuable type of LCA. Nevertheless, one can make the calculation internally just to set up their own policies, not necessarily to declare it externally. How is that made? Clearly, the first thing to do is setting the objective. So define the functional unit. So what am I measuring? Am I measuring 1 kilo? Am I measuring a chair? Am I measuring a component? So what's the unit where I am working on? And define the system boundaries. Then the second step is of the most, let's say, heavy part of it, which is the inventory of extractions and emissions, which include the calculations on the impact of raw material, energy, transportation, products, co-products, waste, emissions for all the components of the system that I have defined. And then we have an impact assessment, so the assessment of the impact that I have calculated, and then the interpretation of results. The LCA determines the units, so we have defined a unit, the unit's overall carbon footprint, which is expressed as a number by kilogram or ton, but normally it's kilogram CO2 equivalent per unit. So especially when it comes to materials, it's important to understand what the unit is. Is it a kilo of a material, a square meter, a watt? Or if it's a tile, when we are talking about tiles, for instance, the single unit. So that's also important. Clearly, CO2 in this case, you probably know it very well, is not necessarily CO2. That equivalent means that any other emissions is measured by CO2 equivalent units. So for instance, methane corresponds to 25 times the impact of CO2. So let's say 1 kilo of methane is 25 kilos of CO2 in terms of calculating the overall impact. So this is an example of how a material can impact the LCA and the overall carbon footprint of a unit. In this case, we were talking about an object that could be made out of plastic or out of paper pulp or out of paperboard. So the different LCAs calculated the different impacts on the same unit, so on the same object, using different materials. So the object of reference was polypropylene, virgin polypropylene, where we see that the raw materials impact is the highest. So in the case of the object made out of virgin polypropylene, the area that's covered by the impact of the raw material is the highest. Then we have disposal, which is also quite high, and then very, let's say, small amount in terms of production and transport. So if we replace the same in the same object virgin polypropylene with recycled polypropylene, we would cut a lot the impact of the object itself. So instinctively, one would think that using paper pulp, paper is good, no? It's a good material, plastic is bad, paper is good, and this is it's the mantra that we hear every time. But in this specific case, the company had the idea of replacing polypropylene with the paper pulp, which is the formed paper that is used, for instance, to make eggs containers. Clearly, there would be the need of using a certain thickness, a certain quantity of material to give the same type of performances that plastic would give. And in this specific case, when it comes to the raw material, the impact is quite low because we would talk about recycled pulp. But the impact of the production plant in terms of water, of energy, etc., would be very high, and being even higher than recycled polypropylene. So in this case, the result was interesting because it gave a result that was completely counterintuitive compares with what one would have expected. One thinks of a plastic object, a paper pulp object, and would instinctively think that paper pulp would be better, while instead it is not necessarily so. It would depend on many things, the type of plant, where it is manufactured, the type of technology, etc. So the LCA is super interesting and super useful to also make a comparison of these types of things. Clearly, when it comes to calculating the impact of a product, one should also consider the durability. So, of course, a cardboard chair, let alone the design, do not consider the design, but clearly something that's made out of carbon has a lower carbon footprint of carton, sorry. Paperboard has a lower carbon footprint than a plastic chair. But then when you compare it in terms of durability, then for sure the plastic chair wins, because the durability is much, much longer, and you would need to multiply the impact of one single cardboard chair to compare it with in the same time perspective as a plastic chair. So is that clear so far? We have not the questionnaire, so I just would like to make a short 5-minute break to ask you whether it is clear, whether it is okay, if you have questions, if everything is totally understandable.
So I remember the attendees that there is the chat if they want to put some questions. At the moment, all the participants say that it's all clear. I don't know if you want to.
Yes, I see the chat. So, but if you have also some question, or maybe some, maybe I ran too much. I don't know. Okay. So we have here now some examples. Am I running too much? Maybe I should go a little bit slower.
No, I think it's
No,
very
okay.
clear, step by step.
Okay. So the second group is that of I would like to go through some sustainability policies and they're told via some design case studies. So we try to summarize some possible paths towards circular strategies. Some of them can be more, let's say, easy, obvious, and also we would like to tell some examples of how these strategies have been put into place. So the first and more instinctive is that, especially when it comes to materials, is that of recycling. So in this case, the focus is the physical material. And normally these type of strategies that that address recycling are more applied to disposables, to materials like single use, packaging, etc. In this case, the strategies is more about waste, the material content, so reducing the quantity of material, recyclability, even industrial symbiosis, so exchanging, let's say, what's a waste for me can become a resource for someone else. So it's a material recovery. We will get these slides after the webinar. Yes, of course. Then we have net zero, which focuses more on CO2, so on carbon footprint. So clearly, the actions in these cases are LCA, the impact of processes and transport, the use of renewable energy, etc. Then life extension, which is instead much, focusing for, let's say, more on durable products, but not just that. There are some interesting cases of switch from, of servitization strategies that are applied also to disposables. So moving from disposable goods to durable goods that are provided as services. So when we talk about life extension, we talk about the durability of repair, design for disassembling, and to servitization. And the fourth leg, I would say, is that of protect and regenerate, where the focus is environment and society. And here, clearly, all the concerns are about traceability. So where does my material come from? Is the manufacturing or the growth or the sourcing of that material affecting someone somewhere? How can I restore the natural environment where I have taken that material from? And can I impact positively on socially on the place where I outsource my production or where I take the material from, etc. So it's a more, let's say, holistic and social type of approach, even when we talk about materials. So more in focus. Recycling. The material strategies, clearly, well, that's pretty easy. we talk about recycled content, of recyclability, and materials from waste. We will discuss more in depth in the next module, both the idea of recycled content and the idea of recyclability, which are very different. And in the fourth module, that of materials from waste, whereas by waste we mean industrial waste, but also agricultural waste. When we talk about net zero instead, the material strategies are about zero carbon emission, clearly, reduction in general of weight, of quantity, of even components, for instance. So making more with less. Lightweight, especially when it comes for all transport, but particularly for clearly transport sector, so automotive, buses, trains, etc., boats. Lightweight is super important. And then the use also of AI and IoT to trace and to calculate. Then we have life extension, which is again something that's more focused on durable goods, and that's about disassembly. Disassembly typically for repairability, and this is something that we will again talk about in the next module. How are products actually recycled and what's the meaning of disassembly for products? Repairability, clearly, so providing, okay, this is regulated, so it's something that companies must do in certain industries, but it's also something that many companies are trying to implement even without being asked by any regulation. Reuse and durability of goods. So it is, as you can see, a completely different approach concerned as the first one, which is recycling. So do it fast, do it recover materials. In this case, it's more prevent materials from being recycled. And the final one is protect and regenerate. When we talk about biomaterials, here there is a very broad number of researches and explorations, and we will talk about this in the third module on how to replace fossil-based plastic with, or fossil-based materials with bio-alternatives, and typically the tension between the need for performances and the need for the material to demolish itself in a way. So the material should be durable at the same time and performing, and on the other hand, should be able to degrade in certain contexts. And this is very difficult in technical terms. So clearly biodegradability makes sense only in some specific applications. Much more interesting is no toxicity, so the removal of certain components, of certain chemical components. This again is strictly regulated, but there are a lot of components of chemicals that are still under discussion, and some companies decided to remove those chemical components and to go for alternatives, even without, even before, I would say, expecting some regulations to come into place and to act before. And then we have traceability, so knowing where materials come from, where the source of my material, is, and be sure that that material doesn't make disasters in the place where it is sourced. So how to translate all this into a practical and some practical case studies. Some examples we tried to select some examples in areas that are close to the sectors where you work. An interesting examples is the Ocean Coil collection by Light Art, which is made by recycled plastic from the ocean. There is an interesting debate concerning whether it makes sense or not to recover plastic from the oceans, because there is a tension between, if we come back to the very first slides, between climate change, global warming, and so CO2 emissions and pollution. So in this case, there is this tension. These plastics are polluting some specific areas. They are not doing anything to global warming, absolutely nothing. And paradoxically, trying to remove that plastic from the water, from the seas, can instead have a negative effect of global warming, because it requires energy, it requires boats that go there and collect that plastic. So what's better? What shall we do? Shall we consume energy to take back that plastic, or and prevent that plastic to go into to pollute that local environment, to go into the food supply chain that we in the end will eat and everything? So it's an interesting debate. Design-wise, this is an interesting collection that makes use of that type of plastic, of 3D printing technologies, to create also interesting visual effects. In many cases, these plastics, so-called plastics from the oceans, are not recovered from the seas, but they are recovered from the beaches. So it's plastics that would naturally arrive on the beaches and would become part of projects, of local projects, to clean also somehow the coastal environment. Okay, no, I'm sorry. Sometimes I take a look at the chat. Another similar example is this collection by Karim Rashid of furniture. It is, again, also this one is 3D printed. It is made by materials from Tide Plastics. This is an American company that has developed also a technology to sort of repair plastic that has been collected from, let's say, the environment. So it's not only post-consumer, which is already a problem for the quality of plastic, but it has also been damaged by UV rays. Being exposed to UV rays is a problem for many plastics that would damage the structure, and so resulting in very low quality plastic. So normally the percentage of recycled plastics, if it comes from the environment, from a collection from the environment, is very low. It goes, it's always below 20%, no more than that. With the technology of this company, that this company has developed to repair, let's say, the chemical links that make plastic performing, this percentage can rise, can be much higher. So you have less need of adding virgin plastic to make your product. Okay. This is also an interesting, okay, this is more like, let's say, conceptual project, but this, let's say, group, it's more a group, an initiative rather than a company. It's called Tire Collective. What they have done is they have developed a device that can be mounted on the car's wheels, tires, on the tires. to collect the debris that tires produce when they run on asphalt, which is a mix of semi-fine dusts. So it's a size of dusts that's bigger than the one that we breathe, and that's part of air pollution and also soil pollution. So it has been calculated that a large amount of these fine grits, I would say, are produced by the running of cars on roads. And what this collective is trying to do is collect these fine dusts and use them as a raw material. So clearly, the meaning of this operation is not collecting the material, is rather to preventing it from being dispersed in the environment and become part of the dusts that finally we would breathe. But it's also interesting the way they are also trying to use these dusts by creating objects where these dusts are incorporated. And okay, these are concepts products, clearly not product. But it's a type of interesting approach to also communicate the project and to tell the importance of reducing also these types of pollution. And another interesting approach is that of Kralroth. You may have seen, if you have visited Interzum this year, they have introduced this sort of experimental type of chair that has no foam. The company is a company that designs and manufactures performance fabrics with, let's say, sort of high-tech constructions where you can have different types, different, let's say, different constructions in different areas of the same fabric, which is designed and calculated in order to have specific performances. And this would be typically applied to office chairs, for instance, or also that type of seats. What they tried to test is a chair, an armchair, where there is no foam and where the comfort is given by the tension of the textile only. And it was interesting. I mean, I tried it clearly just 5 minutes, so I have no idea of what happens after a couple of hours of sitting there. But what's interesting here is the idea of, on one side, of removing materials. So no foam, same performance, or let's say similar performance without the use of foam, which is PU typically. And also an easier disassembly, easier cleaning of replacing. You have a metal structure, and then you have just the textile that's applied externally. But yeah, removing something, it's what drove this type of development. Let's see whether we can do something without foam. Foam in general is one of those areas where all companies are trying to PU foam to find replacements, but there is nothing that is comparable with the quality of and durability of PU foam. Then this is also another example of an interesting approach and to furniture, but also flooring construction. It's a glueless way of mounting, of assembling, assembling boards to create corners, to create parts. This is by Valinge, but there are also other companies that provide similar types of solutions. It is easy disassemblable. So once let's say, if you have a part of your piece of furniture that needs to be repaired, you don't need to theoretically, clearly, that's the type of a service that a company may provide. So the possibility to replace only one part and not the whole drawer and not the whole piece of furniture. It doesn't use glues, so there is no use of that type of chemicals. We have VOCs, emissions also in the application, in the production, and everything, and also much easier recyclability, because there are some non-wood parts that can be easily removed during the recycling process, because they are quite big. So it's not a layer that cannot be removed, but it's a part. And that can, in the sorting process afterward, the recycling can be separated from wood. Before this one, I would go with maybe, sorry, this. Yeah, I'm jumping a little bit because I think that this connects somehow with the Valinge case study. This is this loop kitchen is a project by Stikka, which is a Norwegian or maybe Danish, sorry, I don't remember exactly, company. And what they do is that they have designed a type of modular kitchen that can be, very simply built. So on one side, they reduce all the parts that are not necessary. It is completely and very easily disassemblable. It can be personalized, it can be refurbished very easily, and they do that by creating a digital twin of the piece of furniture of the kitchen in order to keep track of all the parts that are mounted and positioned in which location, and in order to make maintenance and parts replacement easier. Clearly, their target is not specifically the individual user, but rather communities. So that type of social housing, and a type of housing that is more common in Northern Europe, and that they target durability. So high quality of components, easy replacement of damaged parts. Clearly, the product is more expensive than a standard cheap kitchen, but especially in that type of environment where the landlord also provides the maintenance, so provides everything that should be working. And there is also a quite quick turnover of inquiry. I missed the English word, sorry. So, and where maintenance has an important cost, in this case, they have calculated that the costs of maintenance would be reduced over years, and so the product would, in the longer term, would result to be cheaper than buying a standard kitchen, a standard product that would be then need higher maintenance costs. So it's a way of sort of redesigning also the business model and the way the product is sold, and the way also you justified certain prices to make it more interesting for your clients, and at the same time pursuing circular economy policies. So I go back again. Okay, so this is also an interesting case study. This is a lamp from Floss. You all know Floss, I'm sure. These lamps is Almendra. It is designed by Patrizia Ortiola. Here there are two aspects that the company took into account. One is the will of using by the designer of using bio-based materials. So what they selected is bio-based polycarbonate with mass balance. We will talk about mass balance in the next module when we talk about plastic recycling. What's more interesting is the idea of design for disassembly that has been put into place by Floss starting from 2019 on all products that have been introduced after that date. Why so? Because that's basically mandatory. So the 2019 is where it's after the right to repair directives came into place. But the idea of transforming that limit in a way, you are compelled to provide maintenance and spare parts of your products for a certain amount of years. And you can either keep on doing the things as you did before and answer this need, or you can take this as an opportunity to rethink the design of products. And in this case, all the products have been as a let's say primary requirement, designed to be disassemblable in every single detail, which means that only joints, mechanical joints, so no screws, very few, no glues, very few adhesives, positions in the strategically useful places, so using the minimum necessary adhesives, which could be relatively easily openable, so it's not permanent enough to keep the part into places, but also allowing for disassembly. This type of disassembly has been thought for also for end of life. In reality, it makes sense for repairability. It definitely makes sense for repairability. You can basically replace every single part of this lamp if it is damaged from the front layers. It is very easy to remove and to replace of course, the lighting element. Also those, let's say, leaves that are used as lighting elements can be completely disassembled from the frontal part and the back part. So for any scratch, damage of whatever sort, that can be easily removed and replaced. This may sound standard, I would say, but obvious in a way. But I still have lamps at home that have been designed with an old type of design concept. And there are some parts that once they are broken, you must throw away the lamp, and there is no way you can repair it. It is very, very difficult. You want to break it somehow. And also you can transform the lamp by using other modules and changing the shape and everything. So in here we have two approaches. One is material centered, which is the bio-based, and the other one is disassembly. Instant ink instead is a way of servitization. I put this as an example because it is a possible trend that may become interesting somehow in furniture. In some areas like office furniture, it is already there. So it's the idea of transforming a product into a service. And in this case, we are talking about consumables, which are cartridges. Basically, the system works with a subscription service where the printer is connected via IoT and tells your inks provider, which is HP, when the cartridge is going to be over. So you would be sent automatically the new cartridge, and you would not remain without your cartridge for print. So it's an interesting way of completely rethinking the service, how it affects circular economy policies. On one side, they have redesigned the cartridge and make it bigger, more suitable for refill. The cartridge can be refilled. They can take care of the recycling of the plastic in case the cartridge cannot be refilled anymore. And also there is no way of, there is no mismanagement of the cartridges, and there is no waste for ink, which is because the remaining is refilled or reused or recycled. So there is a control, let's say, over the cartridge that makes the management of this type of product much more efficient in terms of also of environmental impact. Another approach is that of carbon neutrality, which this is just an example of the last release of the Apple Watch, which it is claimed to be carbon neutral. Again, also in this case, a lot of compensation has been done. They say 25% of emissions. That sounds just too few to be true, but anyway. What's interesting here is the idea of making this type of characteristics, so being carbon neutral as something to communicate and something to say, and a part of the commercial offer, working on every single element, and also in terms, and particularly in terms of materials, to reduce the carbon footprint of the object. The most famous example in the lighting sector of this servitization is Light as a Service by Signify, which you probably know very well. This is a policy that started in 2012 by Philips Lighting in collaboration with the Ellen MacArthur Foundation, where the let's say lighting service was redesigned by creating an offer that would sell lights and not the lamp. So the service would be completely redesigned in terms of commercial offer and transformed from bulk purchase towards monthly or yearly subscription, which was one of the first examples of a trend that would later become quite broad, not just in lighting, but also in other types of services like office machinery and everything. Clearly, it makes sense for a B2B approach, but who knows, maybe for also some private type of again, more of community buildings, of social housing, etc. That would also make sense as well. Do you all know this case, I guess? Okay, this we've seen already. Okay, then two quick other case studies is Project Plus by Federlegno Arredo. It is, let's say, a systemic project to help the shift towards a less impacting industry in the furniture Italian industry that has been launched by the Furniture Italian Association. And that includes several services, among them the material library. We are involved into that. This is why I know well about this project. And then other types of services that are provided to the associates with the purpose of helping them into the transition towards the circular economy. These types of these projects is also connected to another project to build supply chain for furniture recycling, which is being discussed also with the ministry, clearly, not just with Federlegno. And we will talk about that in the next module. And it is an example of a systemic approach. Another example of a systemic approach is putting into place sustainability policy from companies. So not just focusing on the material, but rather on the way the company acts and behave when they manufacture that material. So in the supply chain, this is becoming more and more important, whereas manufacturers of products are asking their suppliers to be compliant with certain sustainability practices, being certified and reducing their carbon footprint, etc. So it's sort of drop-down requirement for better sustainability practices. Okay, so I have, if just 5 minutes break to ask you what is your favorite case study, and maybe write down, or maybe you can have a small, a short talk. if you have anything to say, or your comments, or positive or negative comments on the case studies that we have seen. Don't be shy, say something or write something, or there are well, 38, right? Okay, three spine and sticka. So maybe you make Yappogali make furniture. Yeah, I also like these cases because they're very practical in a way, no? Other comments? Okay. Apple. Yeah, I just have a problem with Apple. I have a problem with Apple in the same way I have a problem with H&M or in general, or the fashion industry in general, where on one side, they try to do things better, and this is good on them. And I also appreciate transparency. Transparency is, maybe I didn't talk about transparency enough, which is one of the key issues. And it is all the discussion about greenwashing that is going in this period is also about transparency. But at the same time, you do better in with a business system that is intrinsically bad. So it intrinsically pushes you to throw away stuff, to change the stuff you've bought, or also even very recently, not to be able to upgrade your product. In the case of Apple, for instance, it has not always been like that, because Apple, in the very beginning, when they didn't make phones, by the way, they would allow their machines to be updated very easily and quickly, and not to make the machine, I'm talking about the CPU, the computers, to last much longer. So you would just replace some parts inside. I know that now it's much more complex because you would need to repair other stuff, but at the moment, when a computer becomes old, or even a mobile, you would just throw it away. And recycling in this specific case is really the last thing that you should do. I mean, it's good because it's better than nothing. But in the electronics, extending the life of products, that's the really important, much more important than anything else. Okay, so very interesting answers. Yes, this is super interesting. I'm a lighting designer, and I'm more concerned about light sources. To produce a LED, the manufacturers works with highly pollution raw materials. I think the light sources are very difficult to trace. That's absolutely true, also because they are all manufactured in China, mostly. And yeah, and that all concerning the area of so-called critical materials and rare earths and everything that, also because there is an increasing quantity of electronics into lamps to control, which is good because they may control the consumption and everything. We didn't focus on this topic because that's more, let's say, system and concerning raw materials. And there is not much that can be done, honestly, but this should be something, yeah, in terms of materials. So, but that's absolutely one of the key issues. Thank you very much, Luisa. Okay, okay. We go now. We have a very big bunch of things to say, but what's the role of materials in all this? We are now moving a little bit more towards materials. We will do a very quick now overview of the role of materials divided by family of materials. We didn't consider, given the audience, construction materials like minerals. We didn't consider. And we considered not that much papers, for instance. But we try to focus only on those families of materials that can be more relevant for your industries. So when considering a material, one should take into account all its whole journey. Okay, so we start from raw materials. And so the main issues here are a sustainable sourcing, tracing where possible. Tracing is becoming more and more central, and it will become even more central. Renewable content and regeneration of the place, of the environment where I took that material from. Then we have the transformation of that material, starting from the raw materials. And in that case, the process clearly is one of the most important things. The energy, water, emissions, waste. Then we have transport of the material in all the phases. So clearly weight or short supply chain could also be an important issues. Then there is the product design and its manufacturing. And in that case, it's more a design focused and process focused. So how the material is used. So in that case, design for disassembly, efficiency in application. So there are some materials that are designed, and we will see some examples, to be more efficient, for instance, to require. Sorry, can you please switch off the microphone? Can you please switch off the microphone? Thank you. Cristina, can you please switch off the microphone? Thank you. Okay, efficiency in application, and then reduction of waste, so of scraps and everything. And then we have the product in use. So, and also in that case, the material can play a role in terms of durability, of weight, of emissions in use, all the VOCs things. And also in terms of efficiency, like energy efficiency, so materials for insulations, for instance, etc. And then there is end of life, so take back, recycling, composting, energy recovery, and landfilling, from the best to the worst, clearly. Landfilling should not even consider it, but it is still. a way of disposing of products, unfortunately. And all this clearly goes under, can be calculated and can be considered into the life cycle analysis. Okay, since not all materials manufacturers have performed the life cycle analysis, clearly considering all these things separately or individually is important when you source and when you choose your materials. So the purpose of this very quick overview that we are having today is also to understand what to consider more by each family of materials. So what materials can be important and can play a role in the circular economy by being circular themselves. So materials that are produced according to circularity criteria, or materials that have a role, that behave in the right way in the product as a system for the circular economy, so supporting circular economy strategies. Examples. This is an example of a board that is like it's a medium density board that's made of waste from coconut plantations with lignin used as a binder. So in this case, what's interesting is that a waste coming from agriculture that would be otherwise incinerated in place, which is something that provokes a lot of local pollution besides CO2 emissions, but also a lot of local pollution, is recovered and transformed into boards. So there is also then VOC things, so reduction of VOCs and everything, but what matters most is that you would consider the recovery of waste to make a durable material. And this is in the biological material, so bio-based. When it comes to technical materials, for instance, this is an example of textile that are made out of a recycled nylon, for instance. This is a Econyl recycled nylon yards. When it comes to materials for the circular economy, instead, we are talking about materials that support circular economy strategies. So materials that are integrated in the design process with a view to circular design. For instance, materials that help the disassembly, materials that help repair, that help life extension, or materials as an element of a broader circularity strategy, for instance, energy saving, lightness, etc. So in the first case, it's like a more of a closed way of looking at the material. In this case, it's the material inserted in the system. So an example is this type of removable glue that is very strong and sticky, but if the traction is applied, the force is applied in a certain direction, but then it can be easily removable if you apply a certain force in a different direction. So, and it is also made out of bio-based plus recycled ingredients. And it helps removing particularly textiles and foams from rigid supports. So in this case, it's a material solutions that helps disassembly. Another example that is not in your sector, I didn't find anything on for energy saving, honestly, in terms of materials, but it is an example of ultralight composite materials for components that are applied for the transportation industry. So in this case, regardless the composition of the material, the effect on the system where the material is applied is super important in terms of reduction of CO2 emissions. Going by family, wood and wood-based, it's also a very important family. In this case, so this is like a very, let's say, quick scheme with, let's say, general information. I wouldn't go very in depth for each of these slides because that would be too long. I would just highlight for each of these families of materials what's more relevant. I would say you will have these slides then, and you can clearly take a look at that. So wood and wood-based materials are, generally speaking, good materials because, as we've seen before, they act as carbon sink. They are also, generally speaking, recyclable and recycled based on the local infrastructure. In Italy, there is quite a good infrastructure for that. So as long as they are traced and sourced in a responsible way, and as long as they are finished, I would say, with materials that are with low emissions, are, generally speaking, good materials. The warning are clearly surface treatments and the chemicals that are contained in binders, in glues and everything. And that's an area where most materials manufacturers are working to reduce that type of chemical impact. Couple of examples of material produced according to a circularity perspective. This is, you probably know it, it's MDF by Fantoni, which contains 50% recycled content. Basically what they have done is that they have designed and built a sorting machinery that would clean the wood chips out of post-consumer recycling. Nevertheless, the quality is still not enough to be used on the surface, because MDF must be perfectly clean and smooth on the surface. So this type of wood chips, of wood fibers, because it's not chips, it's fibers, are used on the core of these boards, and externally we would have virgin fibers. So this is the reason why it's 50% recycled content. Then when it comes instead to solutions that would improve the circularity of materials, this is a printing kit, printing technology provided by Valresa to digitally print directly on chipboard or on MDF, providing decorative effects without with a very thin layer, protective layer, and let's say reducing the complication of the material and making it more easily recyclable at the end of life. So without finishing processes that add layers and layers, it's basically ink and a surface coating. Glass. Glass it's a material that's considered good, although it has, I mean, some issues. So glass is a very impactful materials when it comes to CO2 because of the energy consuming process. It is a very, very long-lasting material, except when it breaks, clearly. It is recycled, but only in packaging application. When it comes to other types of application, like windows or other types of interiors, etc., in that case, post-consumer, it it is very hardly recycled. It is very difficult to recover it, although there are projects to improve the recycling of glass. Normally, what would be considered post-consumer recycled in the glass industry is scraps from glass working companies. So that in some cases would be recovered by the glass factories, big glass factories, and considered recycled content. We will talk more in depth about this in the next module. So the warning would be considering thinking of glass as and not necessarily recyclable material, and considering LCA as a measurement, as evaluate it, compares with other materials. A couple of examples. When it comes to, again, circular material, this is a project that involves Murano glass blowing artisans. Blown glass cannot be recycled because of the pigments, basically, that and additives, that mineral additives that are used to create colors or to create particular effects. So that would be normally landfilled. Of course, it cannot incinerate it. It is glass. So this company, it is a designer actually, has developed a way to finally grind these glass scraps, making it in a paste that can be 3D printed and so reused. Of course, it needs a further cooking in the oven, but with the shorter cycle than normal blow molding of glass. So clearly, relatively to this type of industry, which is always energy intensive, but it is relatively low energy impact, and plus it would recover this type of scraps, creating very interesting objects. An example instead of material that in the glass family that would it has been designed for the circular economy is this glass by Saint-Gobain. It is called Mirrorlight Pure. It is the, let's say, the mirror, it's a mirror, sorry. The mirroring effect is creating via a lead-free layer. It is made reducing or eliminating completely certain potentially toxic substances. And unlike standard mirrors, it is entirely recyclable, clearly, provided the infrastructure. But it is at least technically recyclable, while normal mirror would contain components that would prevent it from being recyclable. Metals, very similarly to glass, they are, in the case of metals, they are actually recycled a lot. They are mostly durable, long-lasting, mechanically resistant, so very good for super durable applications. However, they have a very high carbon footprint and global warming potential. Not just the production process, but also it requires very high temperatures. It releases a lot of greenhouse gases, of chemicals, a lot of water needed. So the impact of making metals is very, very high. So clearly, normally, when using metal, one would try to use less as possible. So to create as structures that are as light as possible, compatibly with the performance required. There are several companies that are providing low impact metals. This is an example of hydro. They are not the only one. There are also others, and both in aluminum and in steel. They provide either varieties with recycled content or with a certified carbon footprint. Hydro can, for instance, claims to have some lines of products with a carbon footprint that's 4 kilos per kilo of aluminum produced, with an average of some says 16, others says 20, but anyway, that's the range of the carbon footprint for standard aluminum, which is much higher than steel. Also, steel factories are making similar projects, providing, let's say, low carb steel. And instead, when it comes to systems, to materials that would support circular economy in use, this is a material from Almeco that is a super reflective sheet that would help maximize the luminosity of the LED of the lighting device. So clearly getting the most out of your lighting source would also help in energy saving during the life of product. So materials can also be used for that. Plastics. Okay, we will talk a lot about plastics in the next modules, but very quickly, the main problem with plastics, also with for durable applications, is its high global warming potential, which is really reduced when recycled materials are used, despite all the controversies on recycled plastics. Clearly, plastic is a super performing material that has been overused on silly and useless applications because it was cheap, lightweight, easy to process. And this is the problem of plastic, not plastic per se. I am fond of plastic as a material. I like it very much. It's super useful, and if it can replace materials with much higher impact, still it should be used with more intelligence than the way it has been used so far. So it's more an perspective of using it in the best way rather than of demonizing the material per se. When it comes to recycled plastics, this is a couple of products by 3B Arredamenti. They make, you know them, I'm pretty sure. They propose this 100% recycled polypropylene laminate for interior decorations. And also several companies provide these types of films, decorative films for chipboard surface finishing that have a recycled content. And they were one of the first to make recycled PET finishings for IKEA many years ago, and they have continued with this type of sourcing of recycled materials. Another interesting perspective is that of master batches, decorative master batches that would eliminate the use of surface finish. So creating with small percentages of additives, some surface effects that could be interesting and good enough to avoid an over decoration like in mold films or painting or coatings, etc., and making the material more simple and more valuable after recycling. Paints and coatings. This is also a very important area. Again, these are clearly all the paints and coatings. The most, let's say, critical part is application. Then there is also some focus on nano coatings, which are interesting because of the reduction of quantity and some specific performances that can be provided, but that's still an area with some debate regarding possible health effects of some nanotechnological coatings. It's a type of debate that has apparently no end, but it's still an interesting area to keep an eye on. And then there are some types of chemicals like PTFE, for instance, that are again undergoing restrictions and potential bans in some areas. So examples of coating solutions. This is a range of powder coating systems that would polymerize with a lower temperature than standard. Most powder coatings companies are developing solutions to reduce the temperature in application and consequently reducing CO2 emissions during application, which is one of the most impacting step. And this is also when we were talking about nano coatings, a type of coating that's based on silica sol gel, and that would deposit a layer of basically glass, nanostructured glass on the surface of metal surfaces to protect it, and reducing in some cases even eliminating the need for anodization or galvanic finishing, which are again one of the most impacting processes and so steps in the manufacturing of metal objects. Yeah, this is still they are still a startup level, but they already made some type of applications, and that has been tested with very good results. Composites. I lost track of time. I don't think that my watch is correct. What's the time?
It's 11:06, so we have finished our time. I don't know if you want to 5 minutes more.
Yes.
I don't know how many time do you need?
Oh, I think 5 minutes would be enough.
Okay.
I had the feeling that because my watch says 53, but I had the feeling that it was sorry.
A little bit late.
Sorry about that.
No, it's not.
Anyway, okay, if you can stay 5 more minutes, anyway, you will have if you have to go, you will have the slides anyway. So,
we have all the attendees, so they are interested on.
Okay, so composite materials. Again, it is a very broad family of materials. You cannot summarize in one slide what are the bads and the goods of composites. But generally speaking, composite, the word says it all, is a combination of different materials. And that makes composite virtually unrecyclable. There are some technologies to recycle composite materials. either standard composites, meaning like, for instance, carbon fiber plus resin, but those are not very much efficient, and they make sense economically only with very precious fibers like aramidic or carbon fibers, because the resin part would be used, would be burnt basically and used as a, let's say, energy recovery for the recycling, but you would lose the resin and you would just recover the fibers. So it doesn't make sense to do that with glass fiber, which is a very cheap material. So other possibilities for that type of composites is grinding them and making something else. There are some interesting examples of that. Other types of composite, typically plastic-based, polyolefin, for instance, based composites with some fillers. Those, like wood plastic composites, for instance, those are recyclable only internally, only by the company that would work them. Post-consumer, they would be incinerated. So clearly, a way of reducing the impact besides the process is, for instance, using bio-based components for resins instead of oil-based components. And this is a solid surface material by Crystal Plant, which is solid surfaces are typically based on minerals, alumina typically, and resins. In this case, the 30% content of resin is bio-based. So it's manufactured with the plant-based polyesters. It is recyclable, again, closed loop, so they can recycle it in their manufacturing plants, but once it's outside the company, that's not recyclable anymore unless the company has a take-back program. And this is also a quite famous example of boards made out of Quadrat textile scraps. They had this huge amount of wood, and mostly wood, I would say, scraps from all their manufacturing steps, from fibers to yarns to weaving to cutting and everything. And they developed this material, which is again a board out of a filler, that's the wool, and a resin. Bi-component resin. Again, this is not recyclable, but it's a way of, let's say, putting ahead the problem in a way. So recovering the waste from a company, and those wastes would be incinerated. There is no other way that could be used. Incorporating that waste into a more durable material, and also somehow replacing other materials that would be otherwise used to make these types of, to make boards instead. So it's a way of, again, pushing ahead the problem, but still, I think it's an interesting way of stocking waste in a different place rather than landfill. This is one of the last textile products. I would go very quickly. Textiles, again, is a very big and broad area. It's a very impacting supply chain from yarn to final product. It has a lot of manufacturing steps. Water footprint is typically one of the most important type of impact that this industry has. Ocean pollution in terms of all the manufacturing steps, and after also in use with microfibers. And then there is a big problem with the recyclability of textiles, despite they are putting into place let's say, collection systems to recycle post-consumer textiles. The technologies are still not there for most of them. So clearly using monomaterial textiles would be ideal. That clearly reduces the possibilities, but being able to recycle textile at the end of life, that would be really great. So in terms of solutions, we have a water-free textile dyeing technology. This has been there for like 15 years. And it is a process that uses basically CO2 in place of water to as a vector to transport the pigment onto the fabric yarn, and to reduce the use of water. And then we have an interesting example of durability. This is, again, comes from a completely different sector, but I found it particularly interesting because it shows how a material, a product that is typically disposable, when I use this type of stockings, they would break. So working on a higher quality yarn to, to improve, increase the life of these products, in this specific case is very important. Again, this is also an area where it is very difficult to recycle this type of products. So improving durability is an interesting strategy. And this can be done with ultra-high molecular weight polyethylene, which is a very durable and resistant type of yarns. Last, leather and leather alternatives, which are very broadly used. Again, this is also a very broad area. So leather is one thing, leather alternatives are other things. They are using the same things, more or less. So they should not be considered as alternatives, but as two different types of materials. Both of them are characterized by by impacting finishing processes, both natural leathers with the tanning, and also leather alternatives that always need some types of finishing, of coloring, of dyeing, of transformation. What I can say about this is that leather alternatives with fancy content like apple, orange, whatever type of waste, the impact should be always LCA certified, should not be evaluated only because it contains cactus fibers or this and that sounds interesting. So these will be very soon be considered greenwashing. So this is something I would warn everyone that looks for these types of materials to have substance behind sustainability claims. So just two examples, one on real leather. So there is a lot of development concerning plant-based tanning processes. This specifically uses some natural tanning agent extracted from olive leaves, which makes the leather itself removes all metal contents. There is also in this case some, let's say, discussion about these plant-based tanning processes, whereas they need a lot of water, and also the durability, so the final durability is less. For some sectors, totally non-sufficient. So yeah, it's still the short blanket. You pull it on one side and you would move it, and covering everything is always very difficult, but still this is an opportunity type of approach. On the other side, this is another company always working with real leather that would again use transparency as a way of communicating their impacts. So instead of hiding behind green claims, I appreciate the way they, let's say, communicate what they do to reduce the environmental impacts of the leathers they provide. It's still leather. I mean, it's animal leather. So here there is the vegan type of reasoning that's something we will talk in the third module. But generally speaking, in this type of industry, I really appreciate the transparency when it comes to communicating the real impacts because there is a lot of misconceptions about leather that are based on decades of bad management, of bad industry practices. So now they do it much, much better, but no one believes them anymore. So again, the transparency approach is much, much appreciated. And then there is this example, for instance, this is one example, but there are a lot of examples like this of vegetable derived leatherette, which is free from toxic agents. It's biodegradable and Ecotex standard 100 certified. It has become very popular in the last couple of years. And yeah, like this, there are many others. Again, I always suggest to ask for an LCA. Personally, I always have difficulties in understanding how a material is one of these leather replacements are actually done. The real content, the real bio-based content, the real content from waste, websites are really full of greenwashing. So be really very careful when you select these types of materials.
Mrs. Pellizzari, I think, okay, we have to close because it's 11:20.
Sorry for the
It was very interesting. So I want to thank the expert, Mrs. Anna Pellizzari from Materially for this technical meeting on life cycle and materials. That was very interesting, very clear, and full of timely insights and practical examples. I remember the attendees that this is the first step of a series of 4 technical meetings that will be held between November, between today and end of January. So the next one will be on 21 of November on recycling loop. After there will be the 5 of December, bio-based materials, and the last one, the 30th of January on industrial waste management. And this kind of this series of meetings will be held on the context of the European project SILEO. So see you soon. I will send you the slides and the registration. So see you on 21 of November. Have a nice day.
Thank you everyone, and sorry again for being late.
Bye.
Goodbye.
Bye.
Thank you.
Thank you. Goodbye.
Thank you.
Goodbye.